Hello, everyone. My name is Barbara Garza, and I will be together with my classmates Joël and Imane talking about climate change impact on coffee production in Mexico and key adaptation strategies, specifically in the states of Chiapas and Veracruz. So for today's discussion, we will be talking about the definition of the agricultural area, climate description, climate change impact, adaptation strategies and their limitations, actionable recommendations, knowledge gaps and limitations, and conclusion. So starting with the definition of the agricultural area, we have coffee in Mexico. The main states that produce coffee in Mexico are Chiapas and Veracruz. That's why we chose those zones. Mexico is the 11th coffee producer in the world and the first in organic coffee, with almost 1 million tons produced in 2019. The states of Chiapas produces 41% of that, and Veracruz around 24%. The producers are almost 500,000 from 14 different states, which are selected in the map. And we will talk about coffee Arabica in tropical zones, which is mainly rain-fed. The production is traditional smallholder farming. So the crop, Coffee Arabica, it's a perennial crop. It's productive for up to 80 years. Its growth, it goes from 4 to 7 years, and then it starts producing the fruit. 8 months after its first, after this, it has its first flowering, and then its mature state and fruit production in the end. So these are the states of Chiapas and Veracruz, which are the zones we chose to do our literature review in our project. The territory of Chiapas and Veracruz are almost similar, with 3.8% and 3.7% of the area of Mexico. The population in Chiapas is almost 6 million people, with 50% of them living in rural. Also, Chiapas is it has the most poverty in the whole Mexico. It's working in agricultural sector is around 600,000 people, 1.5% of Mexico's GDP, and coffee is the fourth most produced crop. The coffee produced in Chiapas is produced around 1,300 and 1,700 meters above sea level. And for Veracruz, the population is a bit bigger. As you can see, there is also people living in poverty, not as much as in Chiapas. This region is more technologically developed. The coffee here is the ninth most produced crop. And here the altitude is not as high as in Chiapas. It's 900 meters above sea level. This is the coffee production in the national coffee production in the year of 2010 to 2019. As you can see, there is a decrease caused by the coffee leaf rust, which we will talk about later, and a stabilization in 2016, which today continues to grow. And so the farm practice that Mexico's coffee producers have is shade-grown coffee. The majority of farmers, as I said, are smallholders with less than 5 acres of land, which is this farm practice is less vulnerable to plagues, and it gives services like soil protection, erosion control, carbon sequestration, and improved pollination, which we will talk about later, and also some other services. The motivation behind this project is that the coffee production in Mexico is giving jobs for 500,000 people. There is an impulse for research also with these practices for climate change resilience. There are a lot of ecosystem services that can be actually validated and are starting to be quantified in these zones that are also very important and protected and very diverse in terms of biodiversity. Organic production can be used as a sustainable model, and also, well, there's the conservation of farming traditions. Okay.
Moving on now to learning more about the coffee plant requirements through comparison between Arabica and Robusta. Arabica is notoriously known to be more sensitive to climate variability, and that's because it has specific requirements. For example, regarding temperature ranges, it requires a temperature range between 15 and 25 degrees Celsius. It also requires constant water availability between 1,500 and 2,500 millimeters. It only grows at high altitude between 900 and 2,000 meters. It is very sensitive to pests and diseases. It may seem laborious to grow Arabica coffee, but it's a high quality coffee with high demand across the globe, as opposed to Robusta coffee, which as its name may indicate, is more robust. It tolerates fewer degrees Celsius more than Arabica. It is grown in lower altitude between 0 and 900 meters, is a little bit more resistant to pests and diseases, but it's on the lower quality range of coffee. Now we're gonna talk about climate description, current climate description, past climate trends, and also future climate projections. The current climate description in Chiapas and Veracruz indicates a tropical savanna climate with a mean temperature range for Chiapas, for example, between 22 and 26 degrees Celsius, an average annual temperature of about 1,980 millimeters, which with the altitude that Barbara talks about actually offer perfect conditions for the growth of the Arabica coffee in Chiapas and Veracruz. The wet season is from June to October and the dry season is from November to May. Now for the past climate trends that indicate an increase in the temperatures on Mexico level of about 2 degrees Celsius since the year 1900, an increase in hot days and hot nights, an increase in the percentage of rainfall that occurs as heavy rainfall, and also an observed increase in the frequency of the major hurricanes that happens between 1970 and 2009. Now for the future climate projections, which is going to be based on the reference period between 1995 and 2014, it is projected to have an increase of 3.7 degrees Celsius by the end of the century for the RCP7 and about 4.5 degrees Celsius by the end of the century for the RCP 8.5. The future climate projections also include projections about rainfall, and almost all of the climate models agree that Mexico is going to endure a decrease in rainfall. On Mexico level, by the end of the century, that's going to go up to -8% for Chiapas and -9% for Veracruz. It's also predicted to have a bigger or more percentage of the annual precipitations that fall during the extreme rainfall days. It is projected to have shorter rainy season and overall more erratic precipitations. The dry spells are also projected to increase, and as well as the maximum number of consecutive dry days. And lastly, it's also being projected that Mexico will endure higher frequency of storms and floodings. Now we're going to talk about the impacts of climate change on coffee production, and more precisely on Arabica coffee. The first impacts we're going to talk about are related to temperature rise and rainfall change. Temperatures of above 23 degrees Celsius for Arabica, they cause an acceleration in the ripening of the fruit development, which leads to the loss of quality, and a continuous exposure to temperatures of about 30 degrees Celsius may depress growth and also cause yellowing of the leaves. The impacts related to rainfall is also very important. It is important to note here that the blooming of the coffee is actually triggered by the first rain in the spring, which is preceded by relative droughts. So if during this relative droughts a longer dry spell occurs, it may hinder the blooming. And on the other hand, on the opposite, if heavy rainfall occurs during this period, which is not expected, it may cause the flowers and the fruit to completely drop from the shrubs. We also wanted to look at the effects on pests and diseases, and for that we have two examples. The first one is a fungus, the coffee leaf rust, which actually prefers Arabica to Robusta. It's one of the biggest challenges that Mexican coffee faces. It's important to note here the coffee, like one of the biggest coffee leaf rust outbreaks that Mexico endured in 2012, which caused a drop in production of about 2.7 million bags, and Mexico spent years after that trying to recover from that outbreak. In this study in 2011, Hindorf and Omondi worked on a data analysis of 34 years, and they showed that greater stages of coffee leaf rust development actually coincides with drastic temperature rise since 2006, which indicate a link between temperature rise and proliferation of the coffee leaf rust. It is also important to note here that farmers have been noticing that the coffee leaf rust is actually moving up the altitudinal gradient, and it's now occurring in very high altitude where it never occurred before, and that is due to the presence of jointly hotter and humid conditions in the higher altitudes. The other example is now a pest, which is the coffee berry borer. And in this study in 2011, it has been shown that the coffee berry borer showed an intrinsic rate of growth of about 8.5 degrees for every 1 degree Celsius increase, which again highlights the link between temperature rise and proliferation of pests and diseases. We also wanted to look on the impacts on ant communities and pollinators. Why are ants important in this context? Because they can be great pest predators, and specifically in the Mexican context, the Azteca ant is a very good predator of the coffee berry borer, which we just talked about. Catherine Ennis et al. In 2019 actually highlighted that ant predation may be affected by the microclimate and seasonal rainfall, and it also showed that the reduced rainfall may have an indirect effect on the predation behavior of ants. For the bee pollination, we're going to start by highlighting the fact that smallholder farmers in Chiapas and Veracruz only depend on natural bee pollination, and they have been observing that after each heavy extreme rainfall, they have been observing events of the die of the bees, which can be explained by the fact that the heavy rainfall kind of washes the nectar of the leaves, and it leaves the bees with nothing to feed on, so it caused bee mortality. Regarding those effects of ants on ant predation and bee pollinators, very few studies actually currently precisely indicate the link between rainfall variability and the effect on those two behaviors. Another impact that is linked to the decrease in rainfall that we talked about can be that decrease in rainfall may cause a lower herbaceous biomass, and we know that in shade ground coffee, herbaceous biomass is very important. It offers hospitable environment for coffee pest predators. It offers a more stable microclimate, and it can also buffers the soil organisms from extreme temperatures. Decreased rainfall may threaten the herbaceous biomass, and if this persists, may actually impede on coffee growth in the future. Extreme weather events are also an important impact of climate change. On Mexico level, it's mostly related to hurricanes, heavy and extreme rainfall events, and storms, which can cause soil erosions and landslides. The picture here is from Hurricane Stan in 2006, and this used to be a very big coffee plantation in Chiapas, which was completely erased by the hurricane. This is a direct effect, but it's actually a result of all the impacts we talked about, which commonly lead to a decrease in the total suitability for Arabica coffee. In the graph, it shows two scenarios, the current one and the 2051, a comparison between the function of Arabica suitability and altitude, and we notice a very clear decrease in the suitability in higher altitude. For example, in Chiapas, it is projected to lose up to 50% of its suitable Arabica growing land by 2050. The last impact which we want to talk about, which can be now a positive impact, which is the CO2 fertilization effect. It can actually lead to an enhanced photosynthetic capacity and also to more efficient water use. But the problem with this fertilization effect, it has been shown that it favors highly intensified systems, but in the case of Chiapas and Veracruz, it's mostly extensive ones. So it may lead to competition between the two, leading to more vulnerability of the smallholders. An important question to ask regarding this impact is, can the fertilization effect actually reduce or even offset some of the climate change negative impacts? And this question is, on Mexico level, still an open question for research. We wanted to end the climate change part of a field observation that were carried in a recent study in 2012, when large-scale smallholder farmers interviewed about the change they noticed, and they mostly witnessing a lack of certainty in the rainfall distribution, reduction in the rainfall during the midsummer, a shortening of the wet season. They also noticed the witnessing abnormally high temperature, the coffee leaf rust that goes up the altitudinal gradient, as we talked about, a prolonged drought, higher intensity of rainfall, and also a reduction in bee pollination. Now I'm gonna leave the floor to Joël to talk to you about the adaptation strategy that we identified during the making of the project. Thank you.
Talking about the adaptation strategy, it's important to remind that our different adaptation strategies are based on better land management and soil management, and also the research of coffee variety that will be more resistant to predicted climate change. So our first adaptation strategy was to carry out zoning of most vulnerable areas to climate change. From the image, you can see the destruction of a coffee land. That was done after a hurricane that was noted in the studied area. And before providing adaptation strategy, it's important, first of all, it's first of all important to find out which are the most vulnerable areas to provide either alternatives to livelihood or specific adaptation strategies to those areas. So our first adaptation strategy was to relocate coffee to higher elevated altitude that can permit to have better. That was said by Imane all to provide better coffee quality. And due to the fact that high elevated area that was not further suitable to climate change are becoming suitable for coffee production, have become now suitable due to increase in temperature. So relocating coffee production to higher altitude can be one of the solutions. But there is a potential of treating to biodiversity because high elevated areas of Chiapas and Veracruz are protected area and forest reserve. Then you have genetic breeding and crafting. It is known as Robusta is more resistant to increased temperature and less affected by precipitation variability. Transferring the gene of Robusta to Arabica can permit to have an elite cultivar, and these different ONG and this research center are working to provide a hybrid variety. But this is going to affect the nature of coffee Arabica, that is known to be organic. And one solution that can be done is to grafting grafting coffee Arabica to the root stock of Robusta. And this, from the example, we show that this is comparing the normal Arabica and the one that was grafted, and you can see that the roots are larger on the other one, and this can be one of the main solutions. But the limit with this strategy is that it can reduce the potential of the quality, the aroma, the taste of the quality that is most demanded. Then the next adaptation was forest conservation at landscape scale. It was found that this have the potential to have a favorable microclimate, can permit to lessen extreme event, and can permit to have the presence of natural pest controllers like birds, and have better soil erosion regulation, carbon sequestration, and also it can permit to reduce leaf rot because it's going to limit wind flow around the farmland. Also, we have diversification of native shade, cover trees, and soil vegetation. It is known that in the study area, it's a traditional reforestry system, and there's no screening and priori study before the intercropping of different species. So it's important to do a screening, either to destroy the trees that do not have a favorable relationship with the plants, and to introduce plants that can provide a better protection of the soil quality and can provide a richer leaf lifter. Also, avoiding weeding during rainy season can be favorable. This can permit to have a better soil temperature, and soil preservation can permit to have a better conservation of the soil during the rainy season. And this study shows an example of intercropping coffee with a macumba plant, macumba palm tree. And the advantages of this species that is already found in Mexico, and the production, the food production of the species from September to January, and why the production of coffee from April to July. And the study did several treatments. That is coffee planted around high density of kumba trees, macumba trees, low density, and here it was an unshaded. And before that, these two different areas, these two different treatment had the best result and the best yield from the coffee production. And what are the advantages of this planting in intercropping with the coffee is that it can provide a favorable climate. It have a higher value of photosynthetical active radiation due to the fact that you don't have very broad leaves and can ease the infiltration of sunlight. It also, this different area show that it has a better soil moisture. These two different areas show that there's a better soil moisture in these different areas, and also there's a higher yield. And one of the important advantages is that it can provide diversification of income, because you can have fruits at two different periods, from the coffee and from the species. But the limitation of this strategy is that there should be an equilibrium balance between plant density and plant spacing, which most of the farmers traditional may not know, may not master directly this adaptation strategy. Then the next adaptation strategy was the government of Mexico is promoting the introduction of Robusta at the expense of Arabica, because 55% of the coffee production there is Arabica. But the problem is with this one is that it's not what is mostly demanded by the population, and also under shade, it has only an advantage when the plants are already older, and when the plants are already older, and also it's only these forms, these clones, that shows have a positive relation when they're under shaded and provided the best output. Then you have testing of new resistant variety. This different study done in India and Brazil brought out this different variety of Arabica to found to be more resistant to increase in temperature. And also those different clones for Robusta was found to be more resistant. And what is mainly important here was a new cultivar coffee that was rediscovered in Upper West Africa that has shown to be 2 degrees more tolerant than Robusta and 6 degrees more tolerant than Arabica, and provide virtually the same taste as a coffee Arabica. But there's more studies that need to be done on the condition of Mexico climate. So this needs to be, there is more confirmation from this strategy. Then the last one is to provide socioeconomic adaptation, that is strengthen community organization, promote livelihood diversification, and promote crop insurance. But there's less support from the government authority and the accessibility.
So finally, I would like to talk about the knowledge gaps which were encountered during the literature review. And they almost have to do with the lack of quantification when encountering data for traditional smallholder farming, because there is a lot of different big sources like FAO or even the government of Mexico that are having different numbers for very important data in order to do projections. And there is a lack of knowledge specifically regarding proof and quantification of observed and direct effects on climate change. There is also the lack of knowledge in the effect that climate change has in ant communities and pollinators, the effect of CO2 fertilization on extensive coffee plantation, plantations and to what extent this counteracts with climate change. And finally, the quantification of the efficiency of possible adaptation strategies in Veracruz and Chiapas. Finally, after looking at the adaptation strategies and the most viable and what is already being done in Mexico and some efforts for research, we have regular surveys so that we can have perception of the farmers, but also signs of diseases. And furthermore, we need these surveys to be more approach by a quantitative method and not so much qualitative to have more data. Then experimentation with new coffee varieties, as my classmate talked about. Further evaluation on the Stenophila coffee potential that was also mentioned. So resistance, tolerance, and how resilient it can be. Conservation efforts that are already being also managed in Chiapas and Veracruz. But however, also with traditional farming, it's very unregulated, so it's very difficult to do. And further studies in Arabica for plant responses in their mechanisms and how they interact with climate change and how they are resilient. And finally, the sensibilization and training of the locals so that they know that there is a problem and that they can fix it with adaptation strategies. Thank you so much.